All right, now we're going to work with bases other than e. So, an exponential function of base a is a to the x power. We can also rewrite it as e to the natural log of a times x power. These follow our usual laws of exponents. Any base a to the 0 power is 1. A to the x times a to the y is a to the x plus y. A to the x divided by a to the y is a to the x minus y, and a to the x to the y is a to the x times y. Those are our logarithm or our exponential rules. If we need a refresher, we will do that. But the definition of a logarithm of base a, the log base a is equal to 1 over natural log of a times the natural log of x. That's also the inverse of the exponential function. Our basic properties of logarithms hold true also, just like before. Log base a of 1 is 0. Log base a of x times y can be separated into log base a of x plus log base a of y. Log base a of x to the n power can be written as n times log base a of x, and log base a of x divided by y can be rewritten as log base a of x minus log base a of y. Some inverse properties also hold true. If y equals a to the x, then x equals log base a of y. A to the log base a of x is equal to x, and log base a of a to the x equals x. Logarithms and exponentials with the same base cancel each other out. So the derivative is what we really care about here. As long as a is a positive real number and it's not 1, and u is a differentiable function of x, the derivative of a to the x power is natural log of a times a to the x. The derivative of a to the u power is natural log of a times a to the u times the derivative of u. The derivative of log base a of x is 1 over natural log of a times x, and the derivative of log base a of u is 1 over the natural log of a times u times the derivative of u. So let's look at how those work. Y equals 2 to the x power. If I want to find the derivative, dy dx, it's exponential, so I take the natural log of the base times the base to the power times the derivative of the power, which is just x, or which is just 1. So there's our answer. Y equals 2 to the 3x power. To find our derivative, we take natural log of the base times base to the power times derivative of the power, which is just a 3. To clean that up just a little bit, dy dx is 3 natural log of 2 times 2 to the 3x power. All right, y equals log base 10 of cosine of x. A logarithm with a base that's not e, not a natural log, the derivative is equal to 1 over the natural log of the base times the inside, which is cosine, times the derivative of the inside. The derivative of cosine is negative sine of x. Derivative of inside is 1. So I could just simplify this a little. Negative sine of x over natural log of 10 times the cosine of x. Sine over cosine is tangent though, so I could actually rewrite this as negative tangent of x over natural log of 10. All right, y equals log base 3 of, oh, that looks nasty. This is why the properties of logarithms are so helpful though. I can actually split this into 2 separate logarithms. So y equals log base 3 of the square root of x minus log base 3 of x plus 5. And actually the square root of x, that's a 1/2 power, so I can make it 1/2 log base 3 of x minus log base 3 of x plus 5. Now I can take my derivative. Dy dx equals 1 over 2 ln of 3 times the inside, so x, minus 1 over ln of 3 x plus 5. There we go. I could combine those by getting a common denominator, but I'm not going to. So you will now practice some.